Okay, so this lesson is about logarithms. Now, logarithm is just a fancy word for an exponent problem. So if I told you that you're going to do the log base 10 of some number and that's going to equal 2, that kind of sounds intimidating, but if you break it down into an exponent problem, this becomes much easier. Okay, so like I said, this is log base 10, so we'll start with our base of 10 and write that down here as a base. We're going to make a circle, and that's going to make these problems turn into an exponent problem. So start with your base. 10 to the second power equals this number. So make that circle. Start here to this power equals this number, and then stop right here. And once you have this little circle down, these problems become much easier. Most everybody out there knows that 10 to the second, or 10 times 10, is 100. So logarithms are just exponent problems. Do this little circle trick, and that helps out. On most of your log problems, that little circle will save your life. Okay, let's move on to the meat and potatoes of logs, and that would be the log rules. So there's 5 main log rules. The first one is that you can't take the log of a negative number. And that is for any base. You can't take the log of a negative number. So if I asked you what is the log base 2 of -5, that has no solution. That's what I mean when I say you can't take the log of a negative number. You can't take the log base 3 either, or log base 10. No log of negative numbers. So that's the first rule. Second rule is the log of 1 is 0. And if you thought about that circle thing I told you, now the reason I'm leaving this without a base is because these work with any bases. This happens to be common log or base 10. If you think about that circle, any base to the 0 power is 1. That's true. Anything to the 0 power is 1. So that means the log of 1 is always 0. So there's another little handy thing to remember about logs. The third thing is you can split up a product. So if I have two things that are multiplied together, and again this is any base, so I'm not going to write the base in there, this is just understood to be base 10. The log of a product, you are allowed to split up that product as a sum of the parts. So in other words, if I said the log of 8, I could break that up as a log of 4 plus the log of 2. And that's because this is really 4 times 2. Okay, so you're allowed to split up a product as two things that are sums. Okay, the next rule is the same kind of rule, only this is with a quotient. So if I have two things that are being divided, any base, log base anything of a quotient, what you're going to do is split up that quotient, except have a subtract sign over here. So this is going to be a difference instead of a sum. Okay, and these two rules are kind of hard to keep separate when you first start doing a lot of logs, but maybe you could remember it that this is a subtract sign and that kind of looks like a subtract sign. Even though it's a quotient bar, those are the same line, so maybe that'll help you keep that straight. Okay, next rule is a power rule. So I have any base and I have a number to a power. So log any base, I have a number to a power. What you're allowed to do is bring the power down in the front and then write that log. So for instance, if I have the log of 8, well, you see 8 can be written as a power like this. So what this rule says is take that power and bring it down into the front. Bring it down in front of the log. Like bring this 3 right here down to here. So log of 8 is the same thing as 3 times the log of 2. Okay. So as I said earlier, there are two forms. There's a logarithmic form and an exponential form. And so logarithmic form looks like this, or like this. It's basically, you have your log, and then there's any base, so let's just write a b there for any base, and then we have your number here. So this is logarithmic form, and usually it'll equal something over here, so we'll say that's an m, or those letters could mean anything. So for instance, if I said the log base 10, which you don't have to write the 10, if there's nothing there, it's understood to be a 10. Log base 10 of 100 equals 2. This is the problem we saw a minute ago. This is true because 10 to the second power equals 100. You'll remember the circle we did. 10 to the second power equals 100. And so this is called log form. Log base 10 of 100 equals 2. If you wanted to change this to exponential form, you would do the circle essentially in your head and write this as an exponent problem instead. And this would be exponential form of this same logarithm. Okay? Now let's talk about the change of base formula. Now, the reason you might need a change of base formula is if you've ever noticed on your calculator, there are buttons for log, log, common log. Now, this is a base of 10, like I've said. And then ln. Now, this is natural log, and it has a base of this number e. And those are the only two buttons on most calculators. This one right here being the easiest button to use. It's usually on the face of most calculators. And if you ever wanted to do a log problem with a calculator, you'd probably want to use this. And the problem comes if I gave you a situation like this, like log base 7 of 9. And I said, what does this equal? Well, even a really good mathematician would have a hard time saying 7 to what power would give me 9. Okay, because this is probably irrational, which means a decimal number that never ends or repeats. And so you might want to use your calculator for this, but your calculator doesn't have a log base 7 button. So you're going to use this change of base formula, which says I'm going to do the common log of the number that's at the same level as the log, I guess you might think of it as, up here, and then put that over the common log of the base down here. Now both of these are common log, log base 10s. You don't have to write that 10. So you'll see in your calculator that this can be done with a button and this can be done with a button, and your calculator will do all of this together. So here's your change of base for any numbers. Log, this works for any base. Let's say there's a number here. So what you're going to do is say common log of the number up here over common log of the number down here, the base. And when I say over, that of course means divide. Remember, both of these are common logs in the calculator.